Okay, so remember for Gauss-Jordan elimination, we're going to apply it using to obtain the reduced row echelon form. Remember, it means that we've got ones on the diagonal, but everything else is a zero. So we can see there's zeros here, here, and here, which means it's in row echelon form, but it's not in reduced row echelon form. So remember, this is our row 1, here's our row 2, here's our row 3. And in order to get everything else to be zeros, I'm going to use those elementary row operations to get this to be a 0, this, and this as well. So let's go ahead and focus on this 4. We're going to do what we need to make it become a 0. So what we're going to do first is we're going to actually back up. Instead of dealing with this one, we're going to go backwards. See, we see that there's a 1 here, and this is perfect. The only thing in row 2 that we don't have is we're going to get rid of this -1. So we're going to add the row 3 to the row 2, because we can see if I added these two together, I'm going to get a 0. So remember, when I have this, that means I'm replacing row 2, which means row 1 is going to stay the same, and row 3 is going to stay the same as well. The only row we're changing is row 2. So row 3 is 0 plus row 2 is 0, so that's 0. Row 3 is 0 plus 1 is 1. 1 plus -1 is a 0, and -2 plus 3 is 1. And that's how we replace row 2. So now that we have that, now we can see, okay, we have, this is a 1, this is a 1, everything else is 0 in those rows. This is a 1, but now we need to deal with this 4 like we talked about earlier. So in order to make this become a 0, because we want it to become a 0, let's go ahead and see what we have to eliminate it with. I know that if I used this row here, I wouldn't be doing anything to change the 1 in the x, because I can't, adding 0 to 1 is just a 1. And then I can multiply this value here by 4 and a negative to add it to this 4 here. So what I'm going to do is I'm going to multiply multiply -4 times row 2 and add it to row 1. So again, this row 1 is what's going to be changed. So I'm going to leave the row 2 alone and leave row 3 alone. I'm just changing row 1. So here we go. I know -4 times 0 is 0 plus 1 is 1. -4 times 1 is -4 plus 4 is 0. -4 times 0 is 0 plus 2 is 2. And -4 times 1 is 4 plus 5 is 9. Oh, sorry. -4 plus 5 is still 1. All right, and then lastly, we're almost done, but we just have to make this 2 into a 0. So how do we make that 2 into a 0? Well, I see here this row has a 1 in that spot. So if I multiplied it by -2 and added it to row 1, that would work for us. So let's go ahead and do that. We're going to say -2 times row 3 and add it into row 1 will give us what we need, which means I'm going to rewrite row 2. Rewrite row 3, keep those, and then now we're going to change row 1. So we're going to go -2 times 0 plus 1 is 1. -2 times 0 plus 0 is 0. -2 times 1 is -2 plus 2 is 0. -2 times -2 is 4 plus 1 is 5. So you can see here that now, dun, 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 we're finally in reduced row echelon form, which tells me that 1x equals 5, 1y equals 1, and 1z equals -2. And that is our solution. We do not have to use back substitution for that. Okay, so for this example number 4, this is what you need that extra piece of paper for. Either use the back of the notes if you want to, or you can use your own piece of paper. This is going to be a pretty lengthy process, so I would definitely get out your other piece of paper for this. Okay, so to solve the following system of Gauss-Jordan elimination. So first thing we're going to do is make an augmented matrix. So here's my augmented matrix. Remember, again, I'm just using the coefficients of 2, -1, 3, and its constant 1. Coefficients of 1x, 2y, -4z, constant -6. Coefficients -2x, 3y, -1z, and 13. So again, we want to put this first in row echelon form, which means I'm going to get these as zeros and these as ones, right? So let's do this one first. First, we're going to get this 2 as a 1. And in order to make this a 1, okay, well, I'm going to go ahead and take a negative or a -1 and multiply it by this row. And if I add it to this, it will make it a positive 1. So I'm going to take negative row 2 or -1 times row 2 and add it to row 1. I'm changing row 1, so I'm keeping row 2 and 3. And now we're going to do the work. So -1 plus 2 is positive 1. -2 plus -1 is -3. -4 is positive 4 plus 3 is 7. And -6 plus 1 is also 7. Okay, so we've got the one that we wanted. Now we're going to need to deal with this 1, and we need it to be a 0. So in order to make this a 0, what if I said, okay, well, now that I have a 1 in row 1, I can go opposite of row 1, or negative times row 1, and add it to row 2. So I'm keeping row 1 and row 3, and I'm changing that row number 2. So here we go. Negative row 1 plus 1 is 0. -3 is a positive 3 plus 2 is 5. -7 plus a -4 is -11. -7 plus -6 is -13. Okay, so we've got the 0 that we want. Now we're dealing with this one, and we want that number to be a 1, because remember, we wanted those negatives, or the ones on the diagonal. So in order to make this a 1, unfortunately, the only thing we can do to this is literally multiply it by a 1/5. So we're going to take 1/5 of row 2. There's no other way to do it. So we're going to keep row 1 the way it is. Keep row 3 the way it is. And now we're multiplying across row 2 by a 1/5. So 0 times 1/5 is 0. 5 times 1/5 is 1. -11 times 1/5 is -11 over 5, or we could call this -2.2. And then -13 over 5, we can write that as a fraction, or we can call it -2.6, which is perfectly fine. Okay, so we've got the one that we wanted. Now we're going to be working on this -2. We want this to become a 0. So in order for that -2 to go away, what if we multiplied row 1, which has a 1 in it, by a 2 and added it to row 3 to change row 3? So keep row 1, keep row 2, and now we're going to change row 3. Here we go. 2, row 1, which is 2 times 1 is 2, plus a -2 is 0. 2 times -3 is -6, plus 3 is -3. 2 times 7 is 14, minus 1 is 13. 2 times 7 is 14, plus 13 is 27. Okay, so we've got the 0 we want. Now we're working on this -3. It also needs to become a 0. So we're going to go ahead, because all we have really is, my first inclination is to deal with this row, but here's the thing. Do you see how there's an X here? I don't want the X to be reintroduced into my row 3, so I can't add it by anything. Otherwise, I'm going to end up with another X, which that will undo the work I just did. So instead, I'm going to take 3 times row 2 and add it to row 3 instead. So here we go. We're changing row 3, so we're keeping row 1 and row 2. Again, we're keeping it the same. And now we're changing row 3. So if we go twice row 2, 0 plus 0 is still 0. Twice of 2 times 1 is 2 minus 3 is negative 1. Oop, pardon me. Not a twice. We're multiplying by 3. 3 times 1 is 3 minus 3 is 0. 3 times negative 2.2 minus 6.4 is going to, or minus 13 plus 13 is going to go 6.4. 3 times negative 2.6 plus 27 is going to give me 19.2. We're almost done. The only thing we still have to do is make this 6.4 into a 1. So all we're going to do is multiply everything by 1 over 6.4 times just a row 3. Keep row 1. Keep row 2. Change row 3. 0 times anything is 0. 6.4 times 1 over 6.4 is a 1. And 19.2 divided by or multiplied by 1 over 6.4 is actually a perfect 3. So this is now in row echelon form. But remember, we wanted to make this reduced row echelon form. So in order to make this reduced row echelon form, we're going to keep going. So I'm going to rewrite what we left off with and keep going from there. So now I want to get, in order to get it reduced row echelon form, I want this, this, and this to be a 0. So here we go. Let's do it. So in order to get these to be a 0, I'm going to work on this negative 3 first. And we're going to multiply row 2 by 3 and add it to row 1, which changes row 1 and keeps everything else the same. So there's row 2 and here's row 1. Or row 3, excuse me, staying the same. Now we're going to change row 1 by taking 3 times row 2, so 0 times 3 is 0, plus 1 is 1. 3 times 1 is 3, minus 3 is 0. 3 times negative 2.2 is negative 6.6, plus 7, and we get a 0.4. And then we go 3 times negative 2.6 plus 7, and we get negative 0.8. Okay, so that's a 0, that's great. Now we want this 0.4 to be a 0. So in order to make this a 0, all we have to do is we're going to actually need to multiply this last row by a negative 0.4, which is the opposite, and then add it into row 3, because we only wanted to change that one number. So if I chosen any other row, it would have added in that middle term, so we couldn't do it. So we had to use this last row, and now we're going to say, well, I'm keeping rows 2 and row 3, and we're changing row 1. So we're going to go, well, 0 times anything is 0, plus row 1 is a 1, so that's that. Negative 4 times 0, again, plus 0 is 0. Negative 4 times 1 is negative 0.4, plus 0.4 is also 0. 3 times negative 0.4 plus a negative 8 gives me a negative 2. So we're almost there. Oh, excuse me, not a negative 2. Pardon me. 0.8. So what we're looking at now is we're going to finish this up and make this a 0 as well. So what we're going to do is we're going to take, the only way to make this a 0, honestly, is if I take this row and multiply it by 2.2 and then add them together. So I'm going to go 2.2 row 3 and add it to row 2, which keeps row 1 and row 3 and changes row 2. So here we go. 2.2 times 0 plus 0 is 0. 2.2 times 0 is 0 plus 1 is 1. 2.2 times 1 is 2.2 minus 2.2 is 0. 2.2 times 3 is 6.6 minus 2.6 will give me 4. And so I messed up on this one up here. When I did that, this is supposed to be a 2, -2. So now this is beautiful because I've got my 1s on the diagonal and 0s everywhere else. So I don't have to use back substitution. I just know this is 1x equals -2, 1y equals 4, and 1z equals 3. You can also use your calculator. If you want to look on that page in your book, it actually gives you the instructions on how to insert a matrix in your calculator. Use an operation called reduced row echelon form, which is this key RREF. If you go second matrix and then math, you can actually do it automatically in your calculator to make sure you got it right. Okay, guys, thanks. Good job.